Hi guys, so today's tutorial is on Grasshopper attractors, and essentially what Grasshopper attractors are is sort of like this magnet that pulls things in your design towards it, and you can control how strongly it pulls and how things are affected when they're closer or farther away from this point or curve. We kind of saw this in the previous tutorial already when we were evaluating the surface and how that gradient of color changed when moving that point around. So a similar thing here, but we're adding more onto that. So first we'll start off with a rectangle that is 20 by 20. And once you have that, we're going to make that into a surface. And then we're going to divide that surface up into 10 by 10. So let's divide the domain. And then we're going to divide it with iso trim. So let's plug in our surface and then our division. So now we have that 10 square grid. From this grid, we want to kind of get each of the faces. So to do that, we're going to deconstruct it. So deconstruct brep. And now we have all our faces. We'd want each centroid of all the faces. So there should be 100 faces, since it is a 10 by 10 grid. And then to get the centroid, we're just going to search up the area. And now we have each center point of the 100 faces. Before we move on, we're going to create our attractor point. So let's search up point. And then in the Rhino screen, let's place a point anywhere on the surface. And once it's on the surface, let's move it up in the z-axis and then set it on Grasshopper. Now with that, we're going to want to kind of find the distance between the point and also the centroids right here, just like previous class. With that, we're going to use closest point. And the P will add in the centroids on which point to search from, and then our attractor point to search to. So once we have that, we are going to try and find the length of the distance. In the previous class we did just a distance command, but now let's use vector because we're going to use the vector for that later. So let's plug in our centroids over here and then our closest points over here. Now we can see that we have kind of each length of each centroid to the attractor point that we created. Now, since that is kind of a lot of data, we are gonna remap it just like we did in the last class. We are gonna want to have all of this data into between the values of 0 to 1. So search up remap, and then we're gonna create a bounds of the length over here, and we're gonna flatten that to just get one number, and we'll plug the bounds into our source, and then our value is just the length of the vector. So once we have these two, we're going to search up graph mapper, and you right click on the graph mapper, and we're going to make it Bezier. So essentially this will kind of be one of the control points with our attractor. Let's plug in our remap numbers. And then once we have each value from 0 to 1, we're going to want to have control on our sort of attractor points over here. So we're going to remap again, plug that in. And then instead of bounds, we're going to construct our own domain. So then we kind of have control. And you're going to see this a little bit later. Let's plug that in into T. And then let's put let's put like 1.5 for now for each of the sliders. And I'm gonna make this smaller by like 0.6. And once we have that, we're just gonna make circles. So just a circle. And for the plane, we're just gonna use our centroids of the faces over here, plug that in, and then we're gonna remap our numbers into the radius of the circle. So now you can kind of see, I'm gonna hide everything else. So you can kind of see what's going on over here. So we have our attractor point here, and when we move that around, the radius of each circle changes. So the closer it is to the attractor point, it's smaller, and the farther it is bigger. And the control for this constructor main is kind of the range of what the radiuses would be. So kind of playing with that, and we can make this smaller. And you can move around the points over there. We could add more attractor points into this command over here. So if we construct more points on Rhino, let's just copy and sort of paste and move this around. And then we have to select both points and set multiple points. And then you can kind of see that both attractors, or both points, are becoming attractors. And now let's do attractor as a curve. So this is really simple. On Rhino again, let's select this point curve command, and let's just draw like kind of squiggle on top of our surface over here. And then on Grasshopper, we're gonna get that curve. Let us set that one curve, and then we're gonna divide that curve up into multiple points. Let's divide it up into like 100. And instead of the point being attached to this cloud list, we're going to use the divided curve. And now you can kind of see, if I hide this, how it's following it. You can move this around. You can play with the control points. And that essentially what an attractor is. So it will follow based on the distance. It will change. So this is changing the radius of the circle. Okay, so now instead of the circles that we had, that we just did, let's make sort of something more 3D. So we still have our code over here, and we're gonna use the edges of our deconstructed B-rep, and we're gonna join those edges to make curves. So join curves, and let's put edges into join. So now we have that. I'm just gonna turn this off. And so we can see here that in the brackets that there are 4 branches of data, but with our remap it's only 3, so we kind of want to match that up so there aren't any complications later on. So we're going to do P shift, and it's just going to shift the paths. So we can now see that it removes sort of one of the branches in our data tree. I think it'll be clearer if I put panels. So I can kind of circle it. So you can kind of see the differences here. There's 4 branches, and then the P shift kind of removes one with sort of this offset command right here. And now it will match with our remap. So it should be 3 branches. Once we have that, we are going to go back, and this is why we used vector instead of distance. We're going to kind of want to create sort of triangles coming up from this grid in a 3D manner. So first, we are going to want to move the center points of each of these centroids. So move command, let's get these centroids over here. But we're going to want to use a vector instead of like in the unit Z. So we're going to use amplitude, and we're going to plug in the vector. And as for the distance and the measured distance, it'll be our remapped numbers over here. And we're going to plug it into the move. Now with these two, we're going to extrude to a point and plug in our curves and then our points. So let's kind of make it a little bit more drastic. So for this, let's change what our attractor is. Let's put it back to the points over here. And then now we could see it is being extruded in the z-axis. If it was the curve, it is kind of flat onto the thing. So we can kind of, if we still have the curve, we can move it up and see that it is following that sort of axis. And if we want to make it more dramatic, we can change our domain. But for now, let's do points, and then let's do custom preview. And now you could see that sort of attractor manner in a 3D way other than just radiuses of curves. And if I move around my point over here, you can see how it is moving based on where the point is. And another sort of point of attraction, we could do an evaluate surface just like the previous tutorial. So let's get an evaluate surface over here. We're going to plug in our surface, and then we're going to get an MD slider. And it's just, you can see our slider is sort of in the corner over there. And again, it's not moving throughout the whole surface, so just remember to reparameterize your surface. I'm just gonna turn this off for now. And let's turn on this so then we could see where the evaluated surface is kind of moving. And similar to the issue we had earlier with the curve kind of being flat or like being in the same plane as the surface, and we want to see those triangles sort of extruded, we'd want to extrude this point of evaluating the surface as well. So let's go move to attach the point there, and then what we want to do is move it in the Z axis, so unit Z, and we can control the height of it, and let's make it like around 10, and now you can see that point is moved up. And then you're just going to plug it in into that cloud component or cloud place, and now we can kind of see that it is following our evaluated point on the surface. And then we could change how close it is, how far it is. Yeah, so those are 3 ways to kind of create attractor points. So one is with multiple points you constructed on Rhino, and then another one is the curve. Let's plug in the curve and see how that kind of follows that pattern, and we can move it up just to make it more extruded. And then again, that evaluated surface. I'm gonna have a different tutorial kind of within the same realm, but we wanna morph this flat surface into maybe a facade.